So you've seen plenty of exponents before. You know that 2 to the third power means 2 times 2 times 2, which is 8. You also hopefully remember that a zero exponent, like 7 to the 0 power, like that, anything with that exponent of 0 is equal to 1. You may even remember that if you take a number with a negative exponent, it really turns it into a fraction and moves that base to the denominator, 1 over 5. But what you might not have seen yet are fractions in exponents. We are looking at rational exponents here today. Rational numbers are numbers that can be written as fractions. So when we use the word rational, you need to think fraction. Now, it's very similar to the word radical, which is talking about roots. So you've got to keep those two words separate. I sometimes use the wrong one when I'm referring to the other one. So got to pay a little extra attention with those words. So let's take a number like 9, and we're going to give it an exponent of 1/2. So do you know what that means? I'll let you think about it for a moment. Take a guess what you think it might mean, and I'll tell you what it really means is this. That's right. A fractional or rational exponent also refers to a root. Now, your denominator of 2, that's telling you which root you are taking. That's how we know this is a square root. So 9 to the 1/2 really means the square root of 9, which we know is 3. Similarly, 25 to the 1/2 is equal to, if you want to rewrite it, you can. If not, you can just think, oh, it's the square root of 25, which is 5. We could put a different denominator, maybe 1/3. That means the cube root of whatever your base is here, 8. We know that that is 2. We could even put a 4th root. How about 81, the 1/4 exponent, I should say. So take a moment, see if you can figure that out. 81 is our base, 4th root. Did you figure out that that is 3? 3 times 3 times 3 times 3 is 81. That's right. Now, sometimes we might mix negatives in there as well. You got to pay extra close attention here. A quick review. Do you remember the difference between these two statements or these two expressions? Are they the same? Are they different? Do you remember how you handle the negatives? The important thing to remember is that whenever you see an exponent, it only applies to the thing that it's right above, which in this case is only the 5. Here, the exponent is above the parenthesis, so it refers to the entire thing. So on that first one, we are only squaring the 5. The negative just comes along. That's going to be negative 25. Here, we're squaring the entire negative number. The negative is grouped within our parentheses, so it also is squared. This is going to be positive 25. The same holds true when we have rational exponents. So if you see negative 16 and then 1/2 as an exponent, could you rewrite that using the radical symbol? Well, what's the base? Just the 16. The square root, and then the negative goes out front. So this would be negative 4. The square root of 16 is 4. The negative just sort of comes along for the ride here. Now, if we put negative 49 in parentheses with a 1/2 exponent, that's then trying to ask what's the square root of negative 49. And hopefully you remember that you can't do that. You can't take a negative, or you can't take the root of a square root of a negative number and get a real number answer. So we say that there is none here. Now, could we do this? Pause and see if you could take the negative number negative 27 to the 1/3. See if you could do that. That's really asking you, what's the cube root of negative 27? And in this case, the answer is, yeah, it is a number. It's negative 3. Why? Because negative 3 to the third power is negative 3 times negative 3 times negative 3, which is negative times a negative times a negative is a negative 27. Now, maybe you've noticed so far that all of the examples I've given you have all been with fractions with a numerator of 1. Every single one I've done so far has been a fraction with a numerator of 1. And maybe you're wondering, can we put other numerators up there? Can we put another number in the numerator? Could we do, for instance, 25 to the 3 halves? Can we? Absolutely, we can. Do you have a guess for what that might mean to do? Take a guess. We already know that the denominator is telling us the root. So let's try to rewrite this. How would we rewrite it? We're taking the square root of 25. I could put a 2 in here if I wanted to. But then what does that tell us? Well, that is just a regular exponent like we always have used. So we would take the square root of 25, which is 5, and we would cube it. Take the square root of 25 is 5, cube it, and we would get 125. We could do 27 to the 2/3. Pause the video and see if you can figure that one out. So we know 27 goes in here. The bottom number is our root. We're going to put parentheses around that whole thing. And then the top number is the remaining exponent. So we're going to start with the cube root of 27, which is 3. We're going to square it, which is 9. One more. I'm going to put a negative 8 in parentheses to the 4/3 power. You are going to finish this. So I'm going to put my negative 8 here, cube root, but then I'm going to take it to the 4th power. What's the cube root of negative 8? Hopefully you found that is negative 2. And then we're going to take that to the 4th power, and that's going to be a positive 16. Now, lastly, regarding evaluating these, we can use negative numbers as our fraction. So we're going to start with a little review here. I mentioned earlier that 5 to the negative first is 1/5. Similarly, I could say 7 to the negative second is 1/7 to the second, which is 1/49, right? When you have a negative exponent, you move where that is in the denominator. One thing you may not remember is that if you have a fraction with a negative exponent around it like that, what happens there? Well, the easiest thing to do here is take your fraction and just flip the entire thing around. Take the reciprocal of that fraction. When you do that, your exponent on the outside becomes positive. We are then left with 9/4. So this idea is going to come into play also when we have negative fractional exponents. So let's see this one. Let's do 1/27 to the negative 4/3. Can you try this? Can you guess based on what we just talked about? Can you figure out what you might have to do here? I'm going to keep going. I would apply this same idea that I did over here. I want this exponent to be positive, so I'm going to take the reciprocal of what's inside. I want this one to be positive, so I'm going to take the reciprocal of this. What's the reciprocal of 1/27? It's 27/1, and you know that you don't even need to write the over 1. We're just going to say it's 27. When I do that, it makes my external exponent there, positive. It doesn't flip it, it just makes it positive. Then we take 27 to the third root here. And once we get that, we are going to take it to the fourth power. The third root of 27 is 3. 3 times 3 times 3 is 27. And that to the fourth power is 81. Look at what we started with here. This. Can you believe that that turns into the value of 81? Probably not what you expected it to. One more. Try this one. 4 to the negative 5/2. So the first thing I would do is deal with this negative exponent. I would do that by taking the reciprocal of the base, right? So we're going to take 1 over 4, and then we are going to have this to the 5/2. Okay? Notice how our exponent became positive when we moved it to the denominator. Now it's 1 over, let's see what happens here, the square root of 4, because of this 2 in the denominator, but then that is to the 5th power. So this is going to be 1 over, what's the square root of 4? 2. And then 2 to the 5th power is 32. So this turns into the number 32. So this was all about, so far, how we evaluate expressions that have rational exponents, right? Anything with a fraction in the exponent. Sometimes they were positive, sometimes they were negative, sometimes they had numbers other than 1 in the numerator. And the last thing we're going to look at is how we simplify exponential expressions with variables and rational expressions. Simplify is going to be our answer. Now, another quick little piece of review before we move on to this. We have already learned things like the product rule and the power rule and the quotient rule. Do you remember x to the 3rd times x to the 5th? How you simplify that when you have bases that are the same and you're multiplying them? You remember what to do to simplify that? We merge them into one base, just a single x. What do we do with our exponents? We add them, 3 plus 5, and this becomes x to the 8th. Another one that we saw was the power rule. Maybe we add x to the 4th, and we put that to the let's say 3rd. This was, again, we can simplify it by only having one exponent instead of 2. There's our base. What do we do with these exponents? Multiply them, and it becomes x to the 12th. So in this case, when they're being multiplied, we add the exponents. Here, where it's a power to a power, we multiply them, and we get x to the 12th. And then finally, we saw fractions like x to the, say, 3rd over x to the 8th. And we can simplify this by subtracting the exponents. We always start with the top one, 3, and subtract the bottom one, 8. Sometimes we do that and get a negative exponent, x to the negative 5th, and we just have to clean that up by, as you know, moving it to the denominator, and that makes that exponent positive. These rules we've been working with for a while, but they work the same whether our exponents are whole numbers, like all of these, or if they're fractions, like the ones that we've been working with already in this video. So let's see what this means. Let's imagine we have x to the 2/3 times x to the 4/5. Now you, of course, can use your calculator to help you with this. You just have to know, what do I do? We want to simplify this, which means we want to merge these into one single base. Instead of two, we just want to have one. So what do we do with our exponents? If you remember from a moment ago, we have to add the two exponents together. Again, this works the same way whether they are positive or negative. So you can use your calculator, of course, to help you with this. And when you do that, you're going to find that 2/3 plus 4/5 is going to be 10 plus 22/15, x to the 22 over 15. That is how this would simplify. That's what this would simplify to, because you had to add those exponents. What if we add the power rule? X to the 2/5, that's grouped in parentheses with a 3/4 outside. Well, just like before, we are going to simplify that by multiplying these two exponents, 2/5 times 3/4. When we actually do that multiplication, we find it's x to the 6 over 20. But even then, we kind of like to reduce those exponents. How about we go it all the way down to x to the 3/10? Sorry, that should be a 10 right there. X to the 3/10. So again, when they are the power rule, power to a power, we're going to multiply those exponents. And then lastly, I'll use a different variable here because sometimes it's nice to see m to the 1/3 over m to the 1/2. We need to simplify this. We have the same base twice. We only want to see it once. So let's write it once, take our two exponents, subtract them. They have to be in this order: top minus the bottom, 1/3 minus 1/2. You can, of course, use your calculator to do this, but what you will find is that it's m to the negative 1/6. Of course, we don't want to leave a negative exponent. So what do? We bring it to the bottom. We bring our entire base to the bottom, down there, but then our exponent becomes positive. So this is 1 over m to the 1/6. So we evaluated exponential expressions with fractional exponents. We saw negatives in there. We saw different numerators other than 1. We saw negative exponents as well. Again, the denominator, whenever you are doing this, becomes your root. The top exponent, the numerator, top of the exponent, the numerator becomes just the new exponent all by itself. And then you take the root and then whatever power you need to. And then finally, we put variables in there and apply the same exponent rules that we had seen in the past when we are trying to simplify these expressions. If it's the product rule, we add the exponents. If it's the power rule, we multiply the exponents. If it's the quotient rule, we subtract the exponents.